Welcome everyone. My name is Abushad. In this video, we will see how to configure Cluster AutoScaler for Kubernetes. Here we are using Amazon EKS. Okay, first let's understand the concept of Cluster AutoScaler, and then we will see how we can create and configure the Cluster AutoScaler. As you can see in the diagram, this is the basic flow of the concept. A cluster autoscaler scales in and scale out cluster node, Kubernetes cluster node, depends upon the resource requirement. For example, if there are ports which are not schedulable due to a resource crunch, then the cluster autoscaler kicks in and creates newer nodes. This depends upon the number of maximum limit and the minimum limit. So the cluster autoscaler, with the help of autoscaling group, maintain a number of minimum nodes, but it can scale up to the maximum limit. All right. So we have seen HPA, which is horizontal port autoscaler, in my earlier video, how it works and how it can detect the resource requirement and increases the ports automatically. So the HPA and the autoscaler can work together to have a proper autoscaling environment in our cluster setup for Kubernetes. Okay, now let's understand the flow here. What are the components we are going to create and how the concept works. As you can see from the diagram, we have a cluster autoscaler which communicates with autoscaling group to increase the number of worker nodes. All right. So the cluster autoscaler is integrated with autoscaling group with the help of a service account and an IAM role. So basically, cluster autoscaler with the help of an IAM role communicates with autoscaling group. And the service account and the OIDC authenticator, this is required for the integration. And this is how the integration between the cluster autoscaler and the autoscaling group works. All right. So this is a basic flow of the concept. Now I am using the same Terraform code which we have used in our previous video so that you guys can easily refer to the older video as well. And if somebody is using Terraform, he or she will be able to use this video to create a cluster autoscaler as well after creating AWS EKS using Terraform. It can be created using eksctl as well, but I'm not using eksctl. Eksctl is much easier and it has some integration with the ASG, which is the autoscaling group. So it is an easy method where we can have a cluster autoscaler in much less number of steps. But for having a proper continuation with my previous video, I'm using the same Terraform code. As I mentioned, it is the same Terraform code. I'm not changing anything other than what we have changed in the previous video, only the instance type, size of the disk, etc. So it will be easy for you guys to follow if somebody have seen my previous video. All right, so let me connect to the terminal where we are going to run the Terraform code. All right, and then we will see how this is created and we'll see the auto scaling in action. So I'm already connected to my client machine. So this is the Terraform code we have in the system. I will put all the links in the description so that you guys can go and refer. All right, so this is the Terraform code which we have used in our previous video. So I'm going to just apply this code. So I'm just going to use Terraform apply here. I'm giving yes here. Okay, now it takes another 10 minutes for completely creating the AWS cluster, EKS cluster, I mean. All right, I will continue this video once the cluster is ready. Okay, now our cluster has been created. So let's have this configuration file copied to our kubeconfig. Okay, so let's copy it. Okay, now let's see here. Yeah, so it is able to communicate to the Kubernetes cluster now. So it will get ports, nodes. Yeah, there is only one node. Okay, so as I told you, I did not change any of the configuration in the code. I keep the minimum and maximum number of nodes as 1. So it is the same. I have kept the number as 1. So we will change it manually from the autoscaling group. If it is required, we can change it from the script as well. So let's see now how we can create the cluster autoscaler. Alright, for that I'm going to refer a documentation from AWS. Okay, so this is the documentation. Okay, so I'm going to use this document. What are the steps involved in this document so that it is easy for you guys also to follow along with me. So let's see the prerequisites here. It says an Amazon EKS cluster to be there, and that is already done. We have created already an EKS cluster, and then an IAM OIDC provider has to be there. So let's create the OIDC provider first. So as I already told you, for service account to use an IAM role, and IAM OIDC must exist for your cluster. So this is why we have to use OIDC provider. Alright, so eksctl is one command which we need to use to create an OIDC. So you have to install an eksctl tool as well. It is a very straightforward command. Put the URL in the description. There is a video. You can go and refer that. Okay, so as we all know that OIDC provider is not set up. So let's copy this command. This is the command to create an OIDC provider for our cluster. So we need to change the cluster name here. Let's see. Yes. As we all know, eksctl invokes CloudFormation template to create the required resources. So currently it has already created an IAM Open ID Connect provider, which is the same as OIDC. Okay, so this has been created now. Now let's go to the next step. Okay, so we have created an OIDC provider. Now the next requirement is that we have in the autoscaling group these tags to be available. So let's go and see the console and see if we have the proper tag for the autoscaling group. So let's go to the EC2. If we come down, we can see the autoscaling group here. Let's select the autoscaling group. If we come down, we will see the tags. So these are the two tags which we need to verify whether it is available or not. So cluster name, cluster autoscaler, cluster name owned, and cluster autoscaler enabled is true. Cluster autoscaler name, cluster name owned, and enable is true. Okay, so it is there. So we don't have to do anything. We can skip this step. Okay, then we need to create an IAM policy and role. Now, this is the IAM policy which we need to create. So as per the documentation, it has to be created with the name cluster autoscaler policy.json with this policy. So let's copy this. Okay, before that, let's copy this file name. Okay, let's go to the home directory and create the policy file. It's already there, so let me remove this. Now I'm going to copy the policy from the document. Okay, so it is here now. Let's go back to the document and see what is the next step. Okay, now I'm going to create a policy. So this is going to create a Amazon EKS cluster autoscaler policy. Okay. The policy document is there. You have seen that I have copied that JSON format to the file. So this is going to create that policy using the JSON file. Okay, now the Amazon EKS cluster autoscaler policy is created. So this is the ARN which we need to keep a track. This is required for the next step. Okay. Now this is where we are creating a role. So basically this is an IAM role which we have seen in the diagram, and it integrates with the service account so that the cluster autoscaler can communicate with the autoscaling group to increase the number of nodes. Okay, so I have missed to mention one important point here. As I told you, the cluster autoscaler integrates with the autoscaling group, and this creates the required nodes. Okay, so the autoscaling group have a launch configuration or a launch template. This is the template of the node, and using this template, the autoscaling group creates the nodes. So as you can see here in the autoscaling group, there is something called a launch configuration here. So this is how it creates multiple nodes. Okay, let's go back and see the documentation. Now I'm going to copy paste this one, paste it here. So I'm just going to copy this entire content from here. So okay, so let's edit the ARN as well as the cluster name here. Okay, so this has been edited. Now let's enter and create the IAM role. Okay, so the CloudFormation is now creating the role. The IAM role and the service account both are created now. Okay, now let's check the console and see what is the new role which the eksctl created for us. Okay, let's go to the console and check. IAM. So see in the roles, if we see, this is the role which you can see eksctl, which starts with an eksctl. So let's go inside and see the ARN, because the ARN will be required in the later steps. Okay, let's copy it. Let's say inside the Kubernetes, the service account which was created along with the IAM role. As you can see here, this is created. Okay, now we'll follow the next step in the documentation. Okay, now this has been created successfully, the IAM role. Alright, now we need to deploy the cluster autoscaler. So we are going to use the same command here. Okay. Okay, so there are so many objects got created, as you can see here. Alright, there is a deployment as well, autoscaler deployment plus autoscaler deployment, as you can see from here. Now let's annotate the service account. So before we annotate the service account, let's see if the annotation is there or not, already exists or not. so that we can skip this step. So let's describe the service account. So for that, we'll say kubectl describe, let's say -n. Okay, as you can see here, the annotation, there is an annotation already there. So we will see if this is the actual one in the documentation. So as you can see here, it is starts with EKS Amazon AWS.com role ARN and the ARN of the role. So let's see if this is the correct one. So the first part is correct, and then let's see the ARN. Let's go to the console and see if this is the correct ARN. This ends with EQT, sorry, EDQ. So this is the same ARN. So we don't have to do anything in this step. So we can skip this step. Okay, let's go to the next step. Okay, this is again to annotate the deployment with the specific annotation. We can see that also. We will go to the kubectl describe and kubesystem deployment and cluster autoscaler. As we go up, we can see there is an annotations here. Actually, it is not there. So we need to do that. This step is required. Let's copy this and run it. So it is patched now. Let's see again. Now, if you go up, you will see that the annotation, there is an new annotation here. So that step is completed now. And now let's edit the autoscaler deployment, and we will have to add these two options there. And if you see, there is an cluster name which we need to edit as well. This was mentioned in the older step, but we did not do it at that step. As you can see here, to edit the YAML file and replace with your cluster name. We did not do this, so instead of doing it in this step, we can do this in this step as well. As you can see, your cluster name has to be replaced with our actual cluster name. Okay, and then we need to add these two options. Okay, let's copy these two options here. Okay, here we need to change it. Okay, now let's add these two options. Okay, so now we have added both these options. Now let's go back to the documentation. Okay, and now we need to change the version which is mentioned in the deployment file. So we are, as of now, we are using 1.20. This is the cluster version we are using. So it says to open the cluster autoscaler release page and then see what to be mentioned if you are using a specific version of the cluster. Let's see what extension we need to use here for cluster version 1.20. We can see 1.22 is there, 1.21 is there. So this is the cluster autoscaler image which we need to use, 1.20.2. Okay, let's go to the documentation and see what we need to do here. So set image, we need to set the image of the cluster autoscaler to 1.20.2 here. Let's copy this command and then let's use 1.20.2. Okay, so the image is updated now with 1.20.2. We can verify this by going inside the cluster deployment. If we come down, we can see the image which we are going to use is 1.20. As you can see here, cluster autoscaler 1.20.2. So this is what the last command has did to the deployment. Okay, now let's follow the documentation. And now we should be able to see some logs in the deployment of autoscaler, which should say us whether the autoscaler is working properly or not. Okay, let's see the logs now. Okay, we should be able to see some logs like these, like static autoscaler, starting main loop, no pod using affinity, filtering out schedulables, no schedulable pod, etc. Let's see if we are able to see that. Yeah, no schedule. Uh, yes, no schedulable ports, no unschedulable ports, etc. So I think this is working fine. The integration is working fine. Okay, now let's see if we are able to increase the number of nodes if there are unschedulable ports. Okay, so the original port autoscaler will automatically increase the number of ports if the load increases. So I'm not using an HPA here. I'm going to directly deploy an deployment with some 10 replicas so that we can see how the cluster autoscaler works with autoscaling group to increase the number of nodes. Okay, so before that, I'm going to change the autoscaling group maximum value to 3. So this needs to be changed so that our cluster autoscaler will be able to increase the nodes. Okay, so for that, first I'm going to change the autoscaling groups maximum limit. Okay, I'm going to EC2 in autoscaling groups. You can see the maximum capacity is here 1. I'm going to edit this and change it to 3. 3 should be enough. Okay, now the maximum capacity is 3 so that the cluster autoscaler can talk to the autoscaler and increase the node to a maximum of 3. I already have a deployment YAML created. This is a very simple nginx deployment. Only thing is that the replica is set to be around 8. Okay, so I will show you deployment YAML here. This is a simple deployment for nginx. Only thing is that I have a replica of around 10 and then the request and limit is set with a CPU of 500 milli and a limit with a CPU of 500 milli. I'm going to just change it to 450 for the request, 450 millicore. Okay, now this is the deployment which I'm going to use. So as you can see from here, I have a T3.small machine which has two CPUs, two virtual CPUs, which is 2000 millicore. Here I am going to create ports which is going to use around 4500 millicores, which is 450 millicore into 10. So that means this will create more than 2 nodes. This should create more than 2 nodes. This is the aim of having a CPU with 450 millicore. Okay, let me save this file and run it to apply. Okay, so deployment is created. Let's see the logs now. Okay, there is something happening here. It is detecting the uh, requirement for the ports. Okay, see there are 7 ports marked as unschedulable. So let me go and check the nodes now. Kubectl get nodes. See there are only one node currently available and I'm going to use a watch command Now here you can see that the nodes are coming up, new nodes are coming up. These are not ready as of now. And let's see the ports details, kubectl. Okay, so I can see only 3 of them are running and the others are pending. So let's go to the nodes and see if these are getting ready now. Yeah, one of them got ready. Yeah, now all of the 3 nodes are ready now. Let's see the status of the ports. See, all of them are now running. So that means our cluster autoscaler has worked properly. It has integrated with the autoscaler, and the autoscaler has created the nodes, required nodes. Pods are now in running state. Okay, so we have seen how the cluster autoscaler automatically scales up the number of nodes when there is a requirement of resources. So we have 3 nodes now. Okay, and there is a cooling period of around 10 minutes for the resources to scale in. So let's see now. We will remove the deployment and see whether the cluster autoscaler is able to scale down the nodes. Okay, let me delete the deployment. Okay, so the deployment is deleted now. Here we see the ports are getting terminated. Now let's see the nodes. Nodes are there. So it takes around 10 minutes now. Okay, I will continue the video once the scale down is completed. As you can see here, now the nodes are getting removed. Okay, now the cluster autoscaler has removed both the newer nodes, and now it scaled back to the original state, which is a minimum of 1 node. Okay, so we have seen the cluster autoscaler and how it works. So just to recap, the horizontal pod autoscaler only will be able to create pods in the existing nodes. So if it runs out of the node, then the cluster autoscaler will kicks in and provision newer nodes so that it can schedule newer pods in the newly provisioned nodes. Okay, so I think you guys have seen the cluster autoscaler in action. Okay, so if you guys have any suggestions, any doubts, let me know in the comment section. Okay guys, we have come to the end of this video. See you in my next video.